Hey weirdos, I miss you guys too. No, just kidding. But I am going to talk to you guys today about acceleration. So if you have this worksheet, you're going to need it right now, okay? But we got to talk about acceleration first. So, a few things you got to know about acceleration is it's basically the same thing as speed, right? And the fact that it involves time and distance. But acceleration is now the change in speed. And you've probably heard of that before because you probably heard someone say, right, like those car commercials say, this car goes from 0 to 60 in 2.7 seconds. And when they talk about that, that's giving you acceleration because they're telling you how fast something starts, how fast it finishes, and the amount of time. So whereas speed is just distance divided by time, acceleration is speed divided by time. But not just speed, the change in speed. Okay, now there's two types of acceleration. Positive and negative. That's it, right? Positive and negative. Positive speed, called acceleration. We just leave it as that. And then negative acceleration. Most people call that deceleration. They're really just wrong. Okay, there's no such thing as deceleration. That's just a term that people use, but in science we say positive or negative to make sure there's no confusion. So positive acceleration means that the object, in this case this ball here, speeds up. Okay, it's going faster, and then deceleration means that it's moving and it stops. So deceleration, moving, stop. Acceleration, start to finish, speeding up. If you can remember that, you're going to be just fine. Of course, you'll have to read the book still for key terms and such. Don't forget you have a test coming up pretty soon. I think it's Friday, and then you have another one coming up the week after that. So you got a lot of stuff to study, but this is going to help you through it. So as long as you understand positive and negative acceleration, you'll be okay. On the worksheet, there's a couple examples for you. And if you go through your worksheet, I'm just going to kind of, hopefully you have it in front of you. I'm going to read it out loud, so I want you to follow along. It says acceleration is the rate of change in the speed of an object. To determine the rate of acceleration, you use the formula below, and it tells you acceleration equals final speed minus beginning speed divided by time. Okay, so final speed is where it finishes. So if you started from where you are now, you're at 0, right? Most of you are seated down, so you'll be at 0 speed. And if you move somewhere, the ending speed, well, that's that. So final speed is, let's say you're moving at, when you're with Coach Char, Coach Carey, and you run the mile, and you're all started the line, and then they say go. Well, that's your starting speed. So that would be beginning speed would be 0, and then whatever speed you hit. Maybe you hit a final speed of 5 miles per hour, 10 miles per hour. So it's usually the bigger number minus the smaller number. But that's not always the case, and I'll explain why. Divided by time. So if you look back, it's A equals V. Now we use V to represent speed. Don't get V confused with velocity. Okay, so A acceleration equals V2, meaning the second of the speeds, the final speed, minus V1, the starting speed. And then all you're going to do is same thing we did before, the 5 steps. You're going to read, you're going to underline, you're going to write the formula, right? You're going to box and substitute, and then you're going to solve it. So it's nothing different than you've done before. We're going to do the same thing over and over. So everyone right now, look at example number 1. Once again, that's on your worksheet. Example 1, and it says a skater increases her velocity from 2 meters per second to 10 meters per second in 3 seconds. So what is skater's acceleration? I don't need to write this on the board. Obviously, it's in front of you, so this works out great. Right? It says here, she started from 2 meters. When she started at 2 meters, so that's our beginning speed. 10 meters per second, that's our ending speed, and our time is 3 seconds. So if you're reading through this, and you want to do the whole 5 steps, we'd read through it, and it asks us for the skate acceleration. We would underline acceleration, step 1. Step 2, we would write down the formula. In this case, the formula is already written on the top for you. A equals V2 minus V1 divided by T. Then we would go back and box the numbers. In this case, we put a box around 2, a box around 10, and a box around 3. 2 would be starting speed, 10 would be beginning speed, or v2, and then 3 seconds would be t. And we substitute it in and look on the solutions, it's already there for you. So you get acceleration equals 10 meters per second minus 2 meters per second divided by 3, which gives you 8 divided by 3, or in this case 2.7 meters per second squared. Now, you'll notice there it says meters m over s squared. Anytime you see m over s squared, automatically know that's acceleration. Okay? Speed will be m divided by s. I'm sorry, speed will be meters divided by this, right? Distance divided by time. So, oh, that's right. Speed would be m divided by s. Acceleration is m over s squared. So please make a note of that because you can be a little tricked. If you have any three of those things, you can always find it. Okay, so we'll get more into that in a second. But right now, turn your page over and go to question 1.